Okay, let's see this very famous series 1 plus 2 plus 3 plus 4 and so on equals minus 1 over 12. And I already draw the graph. And if this is the first video in my channel about this topic you are watching, I suggest you to watch the previous videos, because I already said a lot of things. For example, this is not method, this is a heuristic method, or if you want just something that is similar or can remember math, but it's not math, I know. But this topic, this subject is very coherent, solid, it works. The methods I will explain work very well. And so the question is, if something works really well, maybe it's true. So let's dive in this series. I draw the histogram graph, and it's a bit difficult in this series to analyze because it's not stable. This is divergent, but if we draw, as always, the middle point of each horizontal segment of the steps, we can say this is if we extend this line here, we can see by eye. Now I'm not remembering the correct rule, the precise rule, but we can see this is like inside this part. And if this is the unit, we notice that here it's 1.5. This is 1, this is 2, so this is less than 1/4, because we notice that if we do another step, I will not talk very precisely, I'm not very good in English, I'm not fluent, but on every step we notice this way of changing 1, and this is a half 1, so this must be like in this here, for example, but this is not a precise way. This is minus 1 over 12. Let's see the number way. Actually, there is a method to extract this value via graphic, but we will see in our future videos. It's done by making an associated function. Parenthesis. This, all the terms follow the rule x. The partial sums follow the rule x times x plus 1 all divided by 2, which is x to the power 2 plus x divided by 2. And from this formula we can extract this value, but we will see in the future. So, one numerical demonstration. This is done by Ramanujan. Equal as we put below this series, we will put minus 4s. So we will have s minus 4s equals minus 3s. But this series, which will be 4 times, but with all terms less than 0, negative, we will dilate the terms by 2, by a factor of 2, starting with 0. So 0 minus 4 plus 0 minus 8, because 2 times 4 8. I'm adding this to be more clear, plus 0, plus this is minus 12, because 3 times 4, 12, minus 12, and so on. This is minus for S. I'm doing the sum vertical. 1 minus 2 plus 3 minus 4 plus 5 minus and so on equals minus 3s. This we already seen. We already saw it. So it's equal to 1 over 4, which is equal to minus 3s here. So s equals minus 1 over 12. 1 plus 2 plus 3 plus 4 plus and so on equals minus 1 over 12. Okay. I know someone can say, but how can you know this operation, putting all the zero here, does not change this value? And this is a correct question. And when I was studying this topic, I studied a few years back ago. I noticed this thing, but I followed like a physics model, where I use a model to study. While it works, I use that model. If it does not work anymore, I will change it. So I suppose that this will not change the value, because I trusted this demonstration. Then I continued my studies, and I did another study to check if that choice to accept this dilation was correct. And I found that this was correct. This gives still minus 4s. But, for example, if we make this minus 4 plus 0 minus 8 plus 0 and so on, this is not minus 4s. Why? Okay, we will see in future. So this is a good way. It's the dilation rules we will see in the next videos. So this is very simple demonstration. I know this is not method, so it's not a demonstration. It's like some sort of connection, but I will say demonstration anyways. The graph, we will see it in future videos, because we will use the associated functions. It's more difficult, but this is the main part, and I wanted to treat this topic about this series because it's very, very important, and all studies I started to make started from this series. I was astonished. I didn't know how it was possible, or how can this value be associated to this, and then I started my study. Actually, the study started because a person, I don't know who he was, told me I was studying bullshit. So I started like a challenge to study more about this topic, and then I wrote a book, and I will show to you now. Okay, this is the book. It's in Italian, but it's available also the English version. Infinite series in heuristic, solidity, coherence, and elegance of infinite series in heuristic math. If you don't talk in Italian, it's a very simple language, apart from all the verbs, but the root of the verbs are always the same. Little etymology parenthesis, little etymology speech, you can see how all the words, even in English, are very similar. For example, infinite, series, hin, the same. Heuristic, just the H behind. Solidity, coherence, just an H more, and okay, but it's a small word. Elegance of infinite series, this is different. It's of. In heuristic, math. It's from Latin, math. It's available also the English version. I think on Amazon too. The Italian, yes, on Amazon. If not on Amazon, the English version, you can check on lulu.com. You can find all of in my sites or searching on the internet. It's like lulu.com/spotlight and my name, Andrea Sorato. But in my site, I usually link it below. You can find the links to buy the book. So let's check about this series. Oh, right here. I think, okay, the histogram graph. But I think, okay, I wrote that this graph is not okay with this series. This graph works only sometimes. And let's see if I did something. Oh, this is very nice for the series we talk in the latest video. Okay. Okay, this is very famous graph. Maybe it's not very precise, but okay. And this is the associated function, I think. But I actually don't remember this. It was a few years ago. I don't remember now how the procedure to extract this function, this formula. A lot is also explained on Wikipedia about this series, but I made it also for other series and other methods. Okay, let's check if, okay. Well, there is actually a lot here. In next videos. Okay, see you soon. Bye bye.